Syngenta Vegetable Seeds is committed to developing solutions for the challenges growers face. We understand the importance of developing superior varieties and bringing innovations with real value to the market every year. Our experienced scientists deploy top-notch technology to develop genetic resistances to pests and diseases that spread across fields and greenhouses, negatively impacting production and triggering growers' important economic losses. In tomato, for example, in the past years, the most threatening virus is a Tomato virus, known as Tomato Brown Rugose Virus, shortened to ToBRFV, which is spreading across the globe very rapidly, making it a truly global challenge to address.
Today's plant breeding relies on the use of technologies and omics data, such as genomics, phenomics, to accelerate product development. Genotyping and sequencing technologies are extremely powerful tools that allow us to understand the unique genetic characteristics of each plant involved in our breeding process. So let me give you a few examples. They enable us to tag specific traits of interest and select them from one breeding generation to another one. Additionally, they enable us to predict the performance of each plant and make better decisions like which one to advance to the next generation. In a nutshell, genotyping and sequencing technology fuel data and decision science, optimizing and accelerating our breeding programs to deliver the right products to our growers as quickly as possible.
In vegetables breeding, we are addressing all traits that are important for growers. These include performance trait, quality trait, and resistance to pathogen. Those are major traits for commercial production and growers' income. The use of genotype and phenotype data, as well as environmental characterization, enables us to develop more qualitative products quicker. Data is collected at different stages of the breeding process. It helps us to identify the plants that have the best performance and the highest probability to carry all the important disease resistances. We modulate technical approaches according to the genetic complexity of the trait we are combining. For simple trait, we often use genetic mapping and trait integration, and for complex trait, we use genomic selection.
With molecular marker, we track natural variation present in plant genome. We proceed in two steps. First, we correlate them with the trait of interest in the plant. Second, we select the best predictive markers. For example, in the case of tomato, the genetic traits of interest are numerous. Quality traits such as color, aroma, taste, or shelf life, but also resistant to disease. In recent years, resistance to Tomato Brown Rugose Virus has been a major focus as it spread quickly across the world.
Between the discovery of resistances and the product availability, it can take between 5 to 15 years, depending the complexity of the traits. The overall time frame also includes the pre-marketing testing phase, when we collaborate with the growers who test our varieties and provide some input about the performance of the hybrids. The quick spread of the ToBRFV, a virus transmitted by contact, has enabled us to rethink our processes to quickly deliver resistant hybrid on the impacted market. To deploy our resistances at large scale, we have significantly increased the tomato crop surface and the use of molecular markers dedicated to trait integration. In the tomato fastback cross factory, we have used several techniques, including cell biology, to speed the integration of resistant traits in our edit germplasm. With the combination of all those tools, we have been able to deliver new hybrids for experiment with growers and launch commercial seeds production.
The tomato production is highly impacted by the ToBRFV. This outbreak has been the opportunity to accelerate the tomato breeding process like never before. We accelerate all processes: breeding, trialing, supply chain. And we are now well positioned to supply many new varieties with good yield, good agronomical performance, and even a higher resistance to ToBRFV. This recent outbreak of ToBRFV has been the opportunity to implement the well-proven strategy to develop sustainable resistance into our new varieties. We strongly believe that the genetic resistance is a key pillar when we are speaking about plant protection. Nevertheless, we have many additional pillars which are really important to implement. Crop management, best practices are key for the grower to protect their crops all along the cycle.